Hi guys, welcome to our channel of Sciences and Mathematics. Today we're going to look at a different class of substituted benzene, of course, which is a polysubstituted benzene. But I felt that it is necessary for us to have a small recap of what we have discussed insofar as the substitution of benzene is concerned. So I've named a few molecules, written a few molecules on the board. The first one for the para, ortho, and meta positions that we talked about, of course, I've indicated. This is a substitution at the point that is directly opposite. And this one is at the meta position, of course, can be at this or that point. And this is the, this is the ortho and this is the meta position, which can be this point or this point, respectively. So in that case, of course, we're going to see that the next molecule that is going to follow that has got a double OH group is going to be given the name hydroquinone. So we shall have this one as hydroquinone. Hydroquinone, of course, that's a special name for that one. And then we have the next one that is having a substitution, of course, just like this at the ortho position. But this one has a special name that we're going to name catechol. It's a special name for that compound. And then we have this second last one that is resocinone. And then the last one is cyclic compound, which is having OH, and then there's the functional group for an organic acid there. So this one is known as cyclic acid. So these are some of the special names and others that we have, of course, discussed, a range of them, and this one in disubstituted benzene, which are going to give us a basis for the naming of the polysubstituted benzene that we have said to be our topic of today. So in case we come across such kinds of molecules in our discussion, I hope that we will be able to remember what the names stand for. So in this case, I'll just do away with this so that we move to our topic for today, which is polysubstituted benzene. So I'm just going to So polysubstituted benzene means that it has got substitution at different levels, which are more than two, of course, which we have mentioned and talked about of disubstituted at 2 points. For poly, it's more than 2 points, which of course can be 3 or 4. So in this case, for polysubstituted benzenes, we're going to see that there are different rules that apply from the nomenclature of maybe the aliphatic and organic compounds. Of course, we know that there's a broad of classes of organic compounds, that's from the aliphatic and of course aromatic compounds. So in this case, the nomenclature or the naming of polysubstituted benzenes follow the normal order of aliphatic compounds, whereby if there are substituents at different levels, especially for polysubstituted benzenes, then we're going to consider the order, the alphabetical order, giving priority to the different substituent groups that appear in this kind of a molecule. So in this case, we're going to have different examples of this polysubstituted benzene so that we can be able to name them. So bear in mind that we are going to use the special names that we have mentioned in some of our videos pertaining to the monosubstituted benzenes. So in this case, if I draw the first member or just a molecule on the board, and then we try to see, maybe let me just put it at the center here so that we can be able to be using it as a central one by doing different substitutions instead of drawing a wide range of molecules. So I'll just use this one for that respect. So this particular molecule has 3 different substitutional points, and that one therefore now qualifies it to be a polysubstituted benzene. So therefore, if you look at different groups that have appeared in this particular kind of a molecule, so we said that special names which are given to monosubstituted benzenes. So in this case, if there's a methyl group here that we have said, so we are going to look at this section of the molecule and give it a special name. Of course, we said that molecule goes by the name toluene. So for that case, we're going to name it using that substituted benzene that is known as toluene. And therefore, we're going to count from this point 1, 2, 3, 4, 5, 6. So we have a substitution at point number 2 and 6. So therefore, it's going to be 2 dinitro toluene. So 2 dinitro toluene. So the numbering goes in that specific order that I've put. And then number 2, the order of priorities. Of course, we're going to look at it later for different substituents. In this case, they are just the same substituents of the nitro group. And then let's look at the second example of a polysubstituted benzene. And also try to see how it can be able to be named. So we have this molecule, which is having a substitution at this point for the bromo, and this one for the chloro. And then we have a nitro, an amine group that is attached at that point. So in that case, we named the benzene ring that has got an amine group with aniline. So therefore, that is going to form the parent name for that compound. And then for the substitutions, we're going to count from this point, giving the substituent that appears first from the alphabetical order the first priority. So between B and C, B comes first in the alphabetical order. So this is number 1, 2, 3, 4, 5. So there's a substitution at point number 3 and 5. So therefore, we are going to give this one the name 3-bromo. This is 3-bromo. And then there's a substitution at point number 5, chloro aniline. So that one will be the name, form the name for that kind of a compound. So that is 3-bromo 5-chloro aniline. So let's look at another one as well. So we're going to compare a different or a wide range of molecules so that we can be able to see the sequence in which they are being named for this polysubstituted benzene. So we have this one, and it's having 3 bromo groups at those different positions. And then we have a hydro group at this point. So in this case, we had a special name for this category of course, from the monosubstituted benzene. We said this benzene molecule that has a substitution for the OH group is known as phenol, and therefore we are going to count the substitutional points at this is number 1, 2, 3, 4, 5, 6. So there's a substitution, 3 substitutions at point number 2, 4, and 6. So therefore, and we have the parent name as phenol, so we are going to have substitution at 2, 4, 6, tri bromo phenol. So that is going to be the name of that particular compound, which has substitution at 3 points. So we can have a look at another one. So there's this compound that we talked about, of course, which was having a different, unique, special name, of course, which had a methoxy group at that point, or alkoxy, that is the substituent name for general names for that kind of a substance. So we have methoxy or alkoxy group at that point. So that name we had given to this compound that is got a single substitution at this point from the single monosubstituted benzenes. We said its name was anisole. So for anisole, of course, when we're trying to look at substitution at different points, we can see that B comes first in the alphabetical order as compared to N, that it's appearing at a para position. So in this case, if we count from this point, it's going to be number 4 and 4, but due to the rules of nomenclature, the substituents have to be given the lowest priority in numbers. So if we count from this point, it will be point number 5, whereas if we count from this point clockwise, it will be point number 1, 2, 4. So it is number 1, 2, 3, 4, 5, 6, 4 and 6, and this is number 1, 2, 3, 4 and 2, and I'm being 2 and 4. So 2 and 4 is lower than 4 and 6. So we shall name that compound as 4-bromo. This is 4-bromo, 2-nitro, and then there's a parent name there with a special name that we have given to the single substituted benzene with or CH3 group, carboxyl group as anisole. So that's going to be the name for that compound. And then maybe we can look at a few examples, maybe 1 or 2, and then we just have a summary of the order of naming of these compounds. So suppose we had of course a similar compound at this substitution at different points. Now we can look at this compound that is going to be a little bit different, or we use that structure. So we have functional group from acid at that particular point. This is 2, subscript 2. So that's an COOH. So that one is going to be, so in order of priorities, of course I've talked about priorities, we're going to look at how they appear and which molecule is going to be given a priority. So this one is an acid, and this kind of compound or part of the molecule is going to be considered as substituents. So therefore we are going to have this molecule named as 2-phenyl. That's why I've indicated the numbers from that point for the functional group of an acid. So it's going to be 2-phenyl ethanoic acid. For a 2-member carbon for organic acids, that is ethanoic acid. So generally this is how we name polysubstituted compounds, bearing in mind that of course we have special names that we have allocated to compounds that we have named, just like the ones that we have done before for mono and polysubstituted benzenes, and I mean for mono and disubstituted benzenes. Now for polybenzenes, of course we use different, of course, the special names, and as well we are going to look for the order of priorities of parts of the molecule, just like the last compound that I've mentioned on the board. Now there's a special case of a compound that we talked about in one of our videos that is known as biphenyl, which consists of two of course groups of benzene which have been linked together at that particular point. So we have this molecule linked to that one, and we call this one a biphenyl. So in that case, in suppose we have a substitution at different points. Let's put this one maybe at a parallel position with respect to this point. So we have maybe a chloro and a chloro at that particular point. Now there's a unique naming for this kind of a compound, in a sense that we are going to have numbering for the first ring, that is from this point 1, 2, 3, 4, 5, 6. But for the second phenyl group that has got the same priority as this first one, because it's also having a substitution at that point, and the chloro, which is a molecule, we're not going to consider the alphabetical order, nor are we going to consider priority, because the two molecules are of course similar. So we are going to use the numbering for the second molecules using 1', 2', 3', 4', 5', and 6'. So in this case, in naming this, also this biphenyl, in naming this compound, we are going to start, of course, by indicating the position of the two substituents with respect to the numbering that I've done on the board. So the first one we are going to have is 4 and then 4', dichloro, 4, 4', dichloro, and then there's okay, there's a substitution, of course, of some methyl groups at this point which I had forgotten. So there's a substitution for methyl groups at this this particular point, that is a methyl group at this particular point. So it is a 4,4 dichloro 2 prime 6 prime 2 prime 6 prime dimethyl, and then 1 prime, this one and this one, 1 prime biphenyl. So in this case, suppose we come across molecules which are of course similar and having some substrates on it. This is the procedure that we're going to take, especially for the biphenyl compounds that I've listed on the board. But of course, these compounds are not going to be appearing much as such, so we are going to give them the least priority. So maybe we're not going to concentrate so much on them, but for the first three that we've talked about, that is for the mono, di, and polysubstituted benzenes, they're going to lay a basis for us in trying to find other organic compounds of similar structures that, like the ones we have listed on the board. So for that case, that is it today for this discussion of substituted benzene, guys. So I hope that the last two discussions that we have had for mono and bi-substituted benzenes and the polysubstituted that we have done for now is going to assist us try to tackle some of the problems and identify the molecules that we come across in different discussions. So for that, okay, I thank you. God bless you. Bye.